Hello everyone, I am Harshal Wagmare and I am explaining the topic Curie point. So let's see what is the Curie point. Curie temperature. The temperature below which a magnetic material behaves like a ferromagnetic material and above which it will behave like a paramagnetic material is called the Curie temperature of that material. It means that when a material hits up to the critical temperature, which means that it is behave like a paramagnetic material after that temperature is known as the Curie temperature. So who discovered the Curie temperature? Pierre Curie, Curie, French physicist, was discovered the critical temperature. He showed that the magnetism was lost at a critical temperature, which known as the Curie temperature. The magnetic orientation of the force of magnetism is determined by the magnetic moment, a dipole moment within an atom which originates from the angular momentum and spin of electron. Material have a different structure of intrinsic magnetic moment that depend on the temperature. The Curie temperature is the critical point at which a material intrinsic magnetic moment change direction. Permanent magnetism is caused by the alignment of magnetic moments, and induced magnetism is created when disordered magnetic moments are forced to align in an applied magnetic field. For example, the ordered magnetic moment ferromagnetic as shown in figure 1 change and become disordered, and in figure 2 the paramagnetic at the Curie temperature. A higher temperature makes the magnetism weaker, as spontaneous magnetism only occurs below the Curie temperature. In analogy to ferromagnetic and paramagnetic materials, the Curie temperature can also be used to describe the phase transition between ferroelectricity and paraelectricity. In this concept contains the order parameter is electric polarization that goes from a finite value to a zero when the temperature is increased above the Curie temperature. So next we see the graph of the ferromagnetic and paramagnetic temperature. So the as we can see in the graph, when a ferromagnetic element exceeds the Curie temperature, it becomes a paramagnetic element. How can temperature affect the magnet? The temperature at which is found magnetic material that have the presence of external field which contains ferromagnetic properties. From the point of view of rocks, minerals, the ability of elements to maintain magnetism is at 570 degrees Celsius. An example of mineral would be magnetite. In low temperature, if a magnet is at a low temperature, the magnetism of the magnetic will increase. When materials are in an environment with low temperature, the magnetic atoms spontaneously realign themselves, achieving a revival of ferromagnetism, antiferromagnetism, and ferromagnetism. In this case of mineral, the ability to retain magnetism is below the Curie point. In high temperature, if the magnet is at high temperature, the magnetism of the magnet will be affected by the strength it possesses. The increase in temperature leads to conversion from ferromagnetic to paramagnetic, creating an increase in temperature, which is known as the Curie temperature. So nextly we see the when room what is the effect of Curie temperature. At room temperature, iron the spin of the iron metal aligns in a line, and above the Curie temperature the spin of the same material aligns uh, differently. What are the Curie temperatures for different materials? Firstly we see the Curie temperature for iron. For iron, Curie temperature is above the 770 degree Celsius. For cobalt, it is 1130 degree Celsius. For nickel, it is 354 degree Celsius. Gadolinium is 19 degree Celsius. Dysprosium is about to minus 185.2 degrees Celsius. Manganese bismuthide is of 350 degrees Celsius, 357 degrees Celsius. Manganese antimonide uh, has a 314 degrees Celsius. Chromium oxide has 113 degrees Celsius, and magnesium arsenide has 45 degrees Celsius. So the graph of Curie temperature and the material. So for ferrite, the Curie temperature is nearly about 200 and below 200. For cobalt based amorphous, it has nearly 300 or slightly above of 300 degrees Celsius. For iron based amorphous, it is above 400, slightly above 400 degrees Celsius. And for iron, it is about to 770 degrees Celsius. So Curie temperature in ferroelectric material. So Curie temperature in ferroelectric material, in analogy of to ferromagnetic and paramagnetic material, the term Curie temperature is also applied to the temperature at which ferroelectric material transits to being a paraelectric. Hence, this critical temperature is the temperature where ferroelectric material lose their spontaneous polarization as first or second order phase change occurs. In case of a second order transition, the Curie base temperature T0, which defines the maximum of the dielectric constants, is equal to the Curie temperature. However, the Curie temperature can be 10K higher than T0 in case of first order transition. In ferroelectric and dielectric, material are only ferroelectric below their corresponding transition temperature T0. Ferroelectric materials are all pyroelectric and therefore have a spontaneous electric polarization as the structure are unsymmetrical. Ferroelectric materials polarize in subject to hysteresis, that is, they are dependent on their past state as well as their current state. As an electric field is applied, the dipoles are forced to align and polarize is created. When the electric field is removed, polarization remains. The hysteresis loop depends on the temperature and has a result as the temperature is increased and reaches T0 to T0. The two curves becomes one curve as shown in the dielectric polarization. Thank you.